Hope everyone has seen the last video, which was about the roll cage designing done in SolidWorks, and now we will discuss about the analyzing of the same, which is done in Ansys Workbench. So the first step is to take the design file that we have done, and then we have to save it as step file. So take the file and save it as a step file. Here you can see the format of step file, and then give some name. And then we have to open the Ansys Workbench. You have to open this one. This will take a little time to open, so I opened it earlier. And then we have to take this one, static structural one, and click and drag this one and drop it here. I can give the first one as front impact or something. And then here the engineering data you have to modify. You have to give the details according to a material you have chosen to make the roll cage. So click here, right click here on engineering data and click edit. And then the default one is the structural steel, so you have to change it on and click here to add a new material and simply give chromoly or something, simply one material. And you have to add details you want to add is that you have to give density, and then this one, the coefficient of thermal expansion, and then you have to give isotropic elasticity. You can see how I have added this all. Simply click and drag this one and drop it at the material. So we have added density, coefficient of thermal expansion, then isotropic elasticity, and also then we have to add tensile yield strength, and then tensile ultimate strength. Okay, these are enough. So you have to do one thing. You have to search the material properties of your chosen material and search in Google. You can see here mechanical properties of, if I'm seeing this one, mechanical properties of ASI 4130, then you can see the details. We can get it easily from Google. So take these details and enter it. Also, we can get material properties from SolidWorks itself, so you can see that also. So you can see I given the material properties, and then just close this one. And now we will add the geometry. So right click on geometry and click on import geometry, and then browse and take the file which saved as the step file. This one, Rollcage for analysis, and open that one, and we have imported the geometry. So now we have to do one more thing, that is edit geometry in design modeler. So a window will open like this, and simply click on generate, and the geometry will be shown here. So here we can see 34 parts and 34 bodies. It separate all the material, so all the members. So we have to unite them into one body and one part. So we have to do one option here, that is click on create and boolean, Then you have to select the geometry. Simply click on one member and you have to select Control plus A. That will select all the members. So then after that apply, and then give generate one more time. So here we can see the one, it is now created as one part and one body, so it will be easy for the analysis. So then close this window, and now click on right click on the model and click edit. By this time we will close this SolidWorks file because running both will be a task for the laptop you are using. So people who are having a low RAM computer and all, you can close other files or folders open and do the Ansys work. Yeah, it has been opened, and now we have to check here which geometry has been, you have to click on which assignment has been assigned to this. So here it is structure shell, we have to change it and select the material we have been added. So given chromoly, and then yeah, here we can see mesh and static structure, etc. You have to click on the mesh option and right click on it and insert sizing, and then geometry we will select this one and control A, apply, and then element size we have to give. Generally we can give according to our wish. Our standard default size is 8 mm, so I have given 8 mm of the element size, and then mesh sizing has been given. Then you can right click on the mesh and update or generate mesh, both will be, the effect will be same only. So this will take a little time. So meshing has been done. Simply click on the mesh again. You can see the preview. Meshing has been done. Okay, then next step is to this one, we have to insert force, and then again insert fixed support. We have to give the fixed support and force also. Force means which impact we are choosing. That is, there are four impact, that is for front impact, rear impact, and side impact, and then rollover impact. So first we will make it as front impact. We'll rename this one, and then we are given force and fixed support. So force we have to define it. So select on geometry, and since it is front impact, we have to choose the front members. So okay, chosen it and then apply, and then here we have to change this one, defined by vector, no vector, we have to give by components, and we can see axis here in the this one. So you can see according to this front impact we will give it as minus z direction. Then go to this z one and give minus sign and give the force in Newton. So I will give it as around 14,000 Newton or something, that you have to calculate according to your values. So I'll simply input some value, that 14,000 Newton, and then I'll apply it. Then we have to give the fixed support. We have to choose the tire connecting or suspension connecting parts to make the body fixed at some points. So I will select this one first. and then apply. So force and fixed support are given, and now we have to in solution we have to insert which all solutions we require. So right click on solution and then insert, then total deformation we require, then maximum stress we require, then stress tool, that as factor of safety we will get from this. Okay, I will choose only this. You can choose according to your wish what results you require. So after providing this force, fixed support and then solutions, then we have to right click on solution and solve. This will also take some little time. If you want to know more about the calculation that has been done to get the force, how much force we have to give, then please let me know. I will help you with that. And it has been solved, so we can check total deformation. You can see the image like this. So we will get an idea to give support, give additional support numbers to the rollcage members. It is auto scale, so we can select to scale and see, not a much problem. Then here also we can click on the max and minimum here, so which shows that maximum stress occurring point and minimum stress occurring point, maximum deformation. Then stress tool, we can get safety factor 1.2, it is minimum 1.2. So it's a safe value. If it is greater than 1, then it's a safer value. So it's okay, front and back is okay. And then we will go to next one, which is side impact. So for that we'll close this window. For the next impact, then we will click and drag the static structure and put on this model, and then we will rename it as the rear impact. And then we will right click on this model on the front and back, because this one we cannot do anything. So from the first one, click on this model and right click it, click on edit option, and now we can see the second static structural option. So similarly rename it as side impact. Then we will give force and fixed support as given in the first case. So in force, since it is side impact, then force we will give these numbers. Simply select the control, click on control on keyboard and select all the numbers that you want. I will give these all numbers and then apply. Then here also by components, then we can see the which axis we have to give. We have to give x minus x direction. So next line, give the force and fixed support for this one, and for side impact. Then force we will give it as since it's side impact, we can give a lesser value, lesser force acting. We can give around 8 or something, that you have to do the calculation. Then fixed support the suspension conducting part, then solution, total deformation, then total stress, then factor safety stress tool and maximum equilibrium stress, and solve it. So we can see the factor safety value 1.5, so it is also okay. Then like that we have to analyze the remaining impact, that is rollover and rear impact. So we'll close this window again, and then click and drag on static structure and put on this model, and then we will give it as rear impact, and click on this one, click on model, right click on model and edit. And this one is side impact, then mistake again rear impact. So right click on this and simply rename it to rear impact, and give the force and fixed support. Force values, since it's rear impact, adjust these numbers, and then apply, and here also, and the Z direction. So since it's rear impact, and then we will give a lesser value, like something at 757 Newton or something, and then force and fixed support. Force is giving me 1, and fixed support, apply it, and then for solution, and solve it. Okay, we have got the result. Then we can see the factor safety value 1.4, and we can see the total deformation. Changing it this on auto scale, you can see the deformation will be like this, impact will be like this, and then to scale, then max and new value. Oh. So then last one is the rollover impact. So for that, close this window again. So coming here, we have to give again, repeat the process, put on this one, and here we have to give rollover impact. Here I big mistakenly given impact to a side impact. So then for the rollover impact, we have to click edit option in the model again. So now the last one we have to rename it, then get us rollover. So in rollover also we have to insert that force and fixed support. So rollover also will give some value. We will apply the geometry, these are numbers, the upside numbers, and then apply it, and components. We can check, we have to give the minus value, minus value direction. So y component minus will give some value 8,000, some value 80, and then for the fixed support we will select the numbers, apply it, So then after that apply, then solution we have to total deformation, then total stress, then maximum, where is maximum stress, or then after that stress to maximum stress. We can insert whatever values we require, we have to insert it, all those in the solution. Then after that I click on solution and solve. We can see the values. So this is a preview. Maximum stress will be here, going here. We can see the preview. So maximum stress and minimum stress occurrence points are also given. This color changes, and then we can see the maximum stress also and total deformation. And you can see all this one. So these are all the steps to design, analyze the roll cage. So hope everyone has understood the process and the procedures what that have been done. So thank you.